All right, ladies and gentlemen. So we are talking about lesson 11, and I'm not going to jump the gun, and because usually what ends up happening is like I'll explain the lesson and the title to you guys, and then I go on and I read like the objective, and it's the same thing what I just said. So we're not going to do that. Lesson 11 is titled "This and or That." Okay. So the goal of our lesson, our objective, is that we're going to be understanding how and or probabilities are defined. And we're going to be able to use frequency tables. You guys remember frequency tables? Our little yes, no answer question thingies, right? Frequency tables to compute, aka calculate the probability. Okay. So our essential concept, what's going to be the takeaway of our lesson for today, is that what does A or B versus A and B mean? So when I say A or B, I'm talking about an outcome. I'm talking about an event. So event A or event B, or event A and event B. Okay, so this is like saying, okay, what's the probability of pulling out a red marble and a blue marble? Or what's the probability of pulling out a red marble or a blue marble, right? So in the marble sense, it's very basic, right? But when we get to like questions like, what's the probability of a student in our class liking violin music and rap music? Versus what's the probability of a student in our class liking violin music or rap music? Right? Those are things that can overlap, right? But they can also be very distinctly different. So how do we calculate the probabilities of a situation where it's like one or the other, or one and the other, right? These are compound events. Compound meaning combined, right? Combined together. So compound events and two-way tables can be used to calculate probabilities for them. So our frequency two-way tables are going to help us calculate those probabilities for us. Okay. Today's lesson is very basic, honestly. It is. We're not really diving too deep into the probability calculations. We're more talking about the overarching concept. Okay. So you have been learning about estimating probabilities for single events, like what's the probability of liking rap music, right? Or what's the probability of liking violin music? Okay. So we've been doing basic single event probabilities, and we've been doing it through simulations, right? Sample proportions. Today we're going to learn how to calculate proportions when multiple events happen. So remember that to compute, aka calculate probabilities, we divide the total number of outcomes that we're interested in by the total number of outcomes that were possible or that were done. So in order to calculate probability, let's say like 29 of us said that we like rap music out of 100 kids, right? So the probability of a student liking rap music is 29, because that's how many like rap music, divided by 100, because that's how many kids we asked, right? So it's the outcomes you're interested in divided by the outcomes that were possible, so the 100 that we did, right? So it's essentially what we got divided by divided by the total. That's what we're looking at here for probability. So we're going to kick things off with an IDS journal entry. Okay, so the first two questions in your lesson 11 journal are, how would we compute, aka calculate, the probability of two outcomes occurring at the same time? So this is an and situation. How would you calculate the probability of two things happening at the same time, right? Rock and rap, or violin and rap. So for example, in your IDS class, what is the probability that a randomly chosen student likes both pickles and mayonnaise, right? Versus the second question here, which is, how would you then compute the probability of either of two outcomes occurring? So what's the probability of a student liking pickles or mayonnaise? Okay. So I want you guys to spend 3 minutes, and this is more of a question of how would you calculate it? Think about it. If it's an and situation, how would you end up calculating that? If it's an or situation, how would you end up calculating that? So you can think of it as like, okay, I have the numbers, what would I do with the numbers? You can think of it as, how would you get the numbers, right? what would you do to figure out how many people like mayonnaise or pickles or both or none or whatever, right? What would you do? So think about it, 3 minutes, write down your ideas, and then we'll share. All right, ladies and gentlemen. So can I please get some volunteers to share in the chat before we get in-class volunteers to share? I will call out names if people do not volunteer. Okay, thank you, Janelle. Well done. Janelle says we can divide the probability. Absolutely. Okay, when they are occurring at the same time. Oh, okay, so take the same time and then divide and get the probability by dividing. Okay, that's an idea. I like it. Any other takers? We got Janelle here with our participation points. Matthew, where are you getting those numbers, buddy? These are like, Okay, Val, when it happens at the same time, multiply, possibly, yes. I like the idea of the combining. Okay. Any other takers? Let's see. I'm gonna call out a few people. Maya, haven't heard from you. Amani, haven't heard from you in a while. Steph, haven't heard from you in a while. Natalie Munoz, haven't heard from you in a while. Let's see if we can get some participation points here. Remember, those participation points come at the end. All right, what about you guys in here? What do you guys think? Katie, what'd you think? Okay. Okay, so similar to Janelle. Well done. Let me mark your participation here. Okay, what did you put, Munya? Any ideas? No, not even one. There's no right or wrong here. They're just ideas. How would you combine probabilities? Right? If say that one more time. Dividing, okay. 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 Dallas, what you got? Picking on the girls today, apparently. Here. Okay, so are you putting something down? Good. Okay. Let's see. Here, what about, okay, so no one added in the chat from the people I called out? I guess not. I guess you guys don't want participation points. It's cool. All right. So yes, we're gonna actually learn exactly how to calculate, right? And how when we have like the top situation when it's pickled and mayo, how do I calculate the probability there? And then if it's pickled or mayo, how do I calculate the probability there? Okay. So we're gonna go through with our activities. Alex, do you have your hand raised because you want to volunteer? Ooh, Dave, there we go. Maya coming through. Combine both outcomes together or use a table. I like that suggestion, Maya. That's a really good suggestion. Okay, Jade says multiply the probability of the first event by the second. Oh, look at the language use there. I love it. Okay, we got Jade here and we got Maya. Okay, Maddie, no worries, hon. No worries, young lady. You're good to go. Okay, so let's take a look at the activity that we're doing today. Your activity is literally your journal, the entirety of your lesson 11 journal, okay? So and after we're done with this activity, what are you gonna do with your journal? Submit it, okay? So what is the activity itself? Now you will learn how to calculate the probability of multiple events, which we call and or. Okay. To do this, you will survey at least 10 people, and you may survey more, okay, and keep track of their food preferences. You will use this table, which is in your journal. I've given you guys a table to keep track of the food preferences of the people that you survey. Next, you will ask each person whether that person likes pickles, mayonnaise, both, or none. Okay, you'll then record each person's answer in the appropriate column and represent their preferences. And then you're going to go through and you're going to use those to answer the rest of the questions in your journal. But before you go off and be like, Ms. Good, there's only 7 of us in here. There's not even 10 of us. I'm pretty sure those of you guys at home, right, it's going to be hard to find 10 people around. So what I did was I created Google Forms for us to fill out with this question. And we're just going to take our class data and use our class data. So what I'm going to do is, those of you at home, I'm going to push the link out in the chat. So I'll push this link out in the chat. And those of you in here, I'm going to send it to you in your Canvas inbox. Okay. So I want you guys to go to your Canvas inbox, and I'm going to go ahead and just mail it to you guys here. Let's compose. Favorite courses, period 4. Okay, so we got Dallas. Oops. Okay, we got Simon. We got Dario. Okay, we got David. Oh. We got Katie. Wait, what is happening? There we go. We got Ethan, and we got Maria. All right, so here is the survey coming to you right now. There you go. So you guys check your Canvas inboxes for the survey, please. Those of you at home on the Zoom, please check your chat. The link is there. So what I'm going to do now is I am going to go to our link here, and I'm going to share the screen in you. Okay. Here we go. So we already got 8 responses. Now we got 9. So keep going. Keep going. Doesn't matter. Doesn't matter. Whichever one you like. Okay. I'm going to take the survey too. Okay. In general, okay, I like both. So I'm going to put my submission there. So we should see Miss K. Ooh, look at that. We're already up to 22. I'm going to show it to you. Yeah, don't worry. Okay, so I should see mine here. Where's Miss K? Right there. All right. So what do we have? We're up to 25 right now. Let's see. We have 27 of you in the Zoom alone. So 26 of you in the Zoom alone, and there's 7 of you in the class, y'all. Yes, we have a big class. Okay, so I should see way more here. Waiting for responses, people. Keep in mind, I can see exactly who's responded and who hasn't. So yes, participation points will be taken away because of this. All right, let's see. I'm gonna give you guys one more minute, and then we're cutting it off. And I'm actually gonna time it so I don't cut it off before the 1 minute mark. Okay. Did I clear everything off my, oh, I did not. Hold on. I was showing the previous period, so I want to make sure everything, okay, I cleared that one off. I just did the top one. So yeah, every period has their own, except 6th period, I only have like 9 kids in there or 8 kids in there. So I always combine it with you guys for them. So there's actually some extra stuff, you know. All right. So 28 responses, we're gonna stick to that. Oh, 29, last minute, all right. If you haven't done the survey yet, don't do it again. So our total is 29. We had 29 students take our survey, okay? So what you're gonna do right now is I'm gonna scroll down to the pie chart, and what we're gonna do is we're going to, instead of doing tallies, you're just gonna write the totals, okay? And the questions are pretty straightforward, but you have to also read what's in the black. So you're gonna answer what's in red, and you're gonna read what's in black, because there are parts in this where the black is really good notes. Okay, so you might want to actually get it, like copy and paste it in your notes. You might want to write it down in your notes notebook, because they give you exactly how to do it after you've tried it. Okay, so right now what you're going to do, though, the first thing you're going to do is we're going to write down our answers of how many people answered each type. You're going to answer the questions as best as you can as you go through, and then at the end you're going to convert those numbers into a two-way frequency table, okay? And if you struggle with that, that's okay, but I still want you to try, because we are going to go over this eventually, right? So I want everyone here, I'm going to go ahead and go to our survey here. Again, we had 29 total, and here is our survey. So pie chart, let me zoom in here for you guys, just in case those of you at home are having a hard time seeing the numbers. I'm gonna hover over each sliver of the pie, and I want you guys to write down the numbers, okay? So the percentages are there, but you want the tally numbers, right? So pickles only is blue. 3 people said pickles only, okay? Mayonnaise only is red, and 11 people said mayo only. Both was 12 people, and none was 3. Okay, so we have 3, 11, 12, and 3. Yes? Okay, so I'll say that one more time. 3, 11, 12, and 3. So what we're gonna do now is I'm gonna give you guys 15 minutes to go through and answer as much of your journal as you can. The goal is to try it out, guys. Goal is to answer the questions as best as you can. Again, don't worry about, you know, getting everything perfect. Try. That's all I ask. Okay? 15 minutes on the clock. Ask questions when you have them, please. All right, so we had 3 for pickles. We had 11 for mayo, 12 for both mayo and pickles, right? And 3 for neither. So if we just go through and we answer our questions here, it says, under your completed table, record the total number of people you surveyed. In other words, how many names are recorded in your table? Well, we surveyed 29, right? So we should have 29 there. To find out how many people like both pickles and mayonnaise, locate the both column and count the number of people. Write down this number. Well, in the both column, we have 12, right? And of course, before you submit this, you're going to change these to blue, right? So we have 12 for the both column. So if I wanted to, so there's a difference, right? There's a difference in the count of people and the probability. So if I wanted to calculate the probability that a randomly selected person would like both, and just both pickles and mayo, right? I would do 12 divided by 29, because the find probability would take that total and we divide it by the total number of people surveyed, right? So count and probability are different, right? Probability is that number over the total, whereas the count is just the count, right? How many people. So when we take a look at this question here, it says to calculate the probability that a randomly selected person from your survey likes both pickles and mayonnaise, divide the number of people who like both by the number. So exactly what I was just saying, 12 divided by 29. So if we actually get that percentage, we were actually given that percentage right here. It's 41.4%. So 41.4%, right? In decimal form, that would be 0.414, right? So how many people from your survey, so now here's a big question. how many people from your survey like pickles? What do you think is the answer? So how many people, right? So I'm asking for you for a count, not the probability yet. How many people from the survey like the pickles? Okay. Maddie's giving me a number.
15.
Dallas says 15. Dario, what do you say? We're going to say 3. How many people from your survey like pickles? What did you say, Katie? 15. Okay. Munya? You, why are you changing it to 15 now? Aha. Okay. So I'm getting 3s and I'm getting 15s. Okay. So you have to look at the language, right? It says how many people from your survey like pickles. It doesn't say how many people from your survey like only pickles. If it had said only pickles, then we'd be like, yeah, 3 it is. But pickles in general, we have our only pickles category, but pickles are also included in the both category, right? Because people who chose both also like pickles. So we have to bring that into play. So over here, it's going to be 3 from the pickles only category plus the 12 from the both category, which is going to give us a total of 15 people who like pickles, right? From the people that you survey. Does that make
was
sense?
my first answer. That's
Okay. Thank you for your participation, Maddie and Janelle. Thank you, Vicky and Matthew. Thank you, Sarai. Okay. And thank you guys in here. So then that brings us this is what explains the whole situation to you, right? If you said 3, it explains why it should be 15, right? Because we have to include the both. It doesn't say pickles only. It says pickles in general. So people who said pickles only plus people who said both like pickles, okay? And then it says, how would you calculate the probability that a randomly selected person from your survey likes pickles? So how do I take that number and then calculate a probability from it? Divide it by? Very good. Those of you at home, thank you, Janelle. What do you guys think? How do you get the probability here? Come on, participate. Thank you, Evelyn. Thank you, Vicky. Yes, yes, divide. 15 divided by 29, our total, right? So over here, we'll have 15 divided by 29. Now this one we do actually have to do ourselves because we don't have this. So 15 divided by 29, oops, turn. What is it? 0.157, really?
no 517.
517. Sorry, okay. Which in percent, right? So to turn that into percent, we do times 100, which is 51.7. So more than half of the people like pickles, right? So 51.7%. There is our probability, right? So we have our count and then we have our probability. Now we ask this question. So that was a both situation, right? That was an and situation. In this case now we have how many people from your survey like pickles or mayonnaise? What do you think the answer is? Okay, so Ethan says 26.
I said 14.
You said 14.
14.
You said 14 as well? You said 14 or 12. Okay, what about you guys? And ooh, the 26 is, I got a 26, 26, 26, and 26 online. So let's see. Ethan, you were the one that said 26, right? Let's see. Okay. So Evelyn said 20. Wow. Look, wow. Guys, I also had 14 here. If you just go with the flow. Okay, I had 12. Just throwing that out there. Okay, those of you at home coming through strong. I like it. I like it. Okay, so 26, 14, and 12 are in the run, right? Did someone say something different? Okay, so how did you get the 26, Ethan?
It's because I added the pickle, mayo, and both.
So you added pickle, mayo, and both. Okay. Okay. So how did you get 14?
I didn't add both. I just did pickles.
You only did pickles and mayo.
Yeah.
You only did pickles and mayo as well. Okay. Okay. So you added 3 columns together. So in this situation, right, it's pickles or mayo. So yes, you have to consider the pickles category the mayo category, but again, you also have to consider the both category, because even the people in the both category, they like pickle or mayo as well, right? So you have to consider that and as well, because those people also like pickles and they also like mayo, okay? So yes, you have to actually consider all three columns. So if the count for your answer in the previous question only included the number of people in the pickles and mayonnaise column, that's incorrect, because people who like both also belong to the group of people that like pickles or mayo, right? So in this case, absolutely, you should have, it should be, come on, it should be 3 plus 12 plus 11, right? Or was it 11 and then 12? It was 11 and then 3 plus 11 plus 12, which gives you the 26, right? Well, good job. Good job, okay? And then, of course, how would you calculate the probability that a randomly selected person from your survey likes pickles or mayonnaise?
26 divided by 29.
Very good. Let me hear it from the chat. Do you guys agree with him? Okay, divide the total number of people surveyed. Yes, divide by the total number of people surveyed. So take your total, right, for pickles or mayo, that's your 26, and divide by the total number of people surveyed. So that's going to be 26 divided by 29, which is going to be quite a high.
0.896.
Thank you. 0.896 times 100 equals 89.6%. Okay, very good. Thank you, Maddie. Thank you, Trin. So if you concluded that the probability would be calculated, right, as the number of people under pickles plus the number of people under mayo plus the number of people under both, all divided by your total number of people surveyed, then you are correct, okay? So then that brings us to our frequency table. Now, this is the one that majority of you guys were having a trouble with. Because I feel like a lot of people at home were like stuck on the table, and then you guys were as well. You're like, how do I do this? It's so much, okay? My suggestion to you is use the intersections, okay? Instead of thinking just mayo and then just pickles, use each intersection as the box. Oh, okay. Up. Leave everything in here, sorry. We'll come back. Okay, guys, I'm sorry, there's a fire alarm going on, so we're gonna pause. So sorry for the interruption with the fire drill, but we are back. Okay, so as I was saying, right, with the frequency table, you wanna think of it as just the intersections, okay? So the top of our frequency table here is, do you like liking mayonnaise, yes or no, right? And the sides, so our vertical yes or no are yes to mayonnaise, no to mayonnaise. And then the horizontal yes or no here, right, is yes to pickles, no to pickles. So instead of thinking it separately, you want to think of it as intersections. So in this box right here, that's the intersection of yes mayo, yes pickle, right? So from our question, right, of pickles, mayo, both or none, which one is yes mayo, yes pickles? Which one of those is yes mayo, yes pickles? From the pickles,
Both.
mayo, both or none? Both, right? Because if someone put both, that means they said yes, they like mayo, and yes, they like pickles. So the fact that we had 12 kids put both means that we have 12 people that said yes to mayo and yes to pickles, okay? And then in this intersection here, this means no mayo, yes pickles, right? So which one of those means no to mayo, but yes to pickles? Pickles only. So that's 3 right there, right? Does that make sense? Yes? Okay. So in this intersection here, right, this is mayo, yes. So which one means yes mayo, but no to pickles? Mayo only, right? That was what, 11? Okay, so this one is no mayo and no pickles. So that's going to be 3 as well, because that's our none category. So the intersections here, right, we had a total of 29 people surveyed. So whatever these totals are should total to 29. So 12 plus 3 is 15. 11 plus 3 is 14. 15 plus 14, 29. 12 plus 11, 23. 3 plus 3, 6. 23 plus 6, 29. We're done with our frequency table. Yeah? So don't think of it as separate questions. Think of the boxes as the intersections. Yes and yes means both. No, yes means one of the onlys, right? No, no means none. Okay? So that's pretty much it for our frequency table. Hopefully that made sense to you guys as well. But as far as our lesson for today, let me go back to the PowerPoint real quick to finish things off. Okay, we had our discussion. We're essentially done for the day. Oh, I apologize. We have some notes on here that you guys want to write down here for our discussion. It says, and or probabilities are called compound probabilities. Let me zoom in here for us. Okay, and or probabilities are called compound probabilities. Okay, so define what you think that means for compound probabilities, and I have a sample definition for you. A compound probability is the probability of some combination of events occurring. So whatever combination, whether it's an and combination or a or combination, right? Compound probabilities means there's a combination of events occurring. Okay, so get that down, please. That should be part of your notes. Once you have that done, I urge you to submit your journals for section 2, unit 2, so that it's not late. Okay, next class period, we're gonna be doing lab 2D. And then on Friday, you'll be assigned your practicum for this section. You'll be given Tuesday in class for the practicum, but only Tuesday. Because next Thursday, we begin unit 2, section 3, okay? We have 4 units total. We only halfway through, not even.
I'll make it.